Vijay, I would request you to please start.
Yeah, thanks, Disha. Hello, everyone. So I'm going to talk about three technology trends in the PCB industry. The first one is the high-speed layout. We are starting to see more and more high-speed interfaces in the PCB design. If you take in the RF world, any design with the 5G or millimeter wave needs a special focus on design and manufacturing. Same goes for the digital, like PAM4 interface with over 100G data rate. So all these layouts need very complex signal and power integrity simulations. And if you on the manufacturing side, you also need to select ultra low loss materials and stack up solutions like HDI constructions with all layer micro vias. This is all if you take a PCB that is designed for a smartphone or a wearable gadget with high speed interface, the careful selection of material and stack up like HTA construction are very critical to ensure that the designs are built first right first time. In this space, Tessolve, as we work with top tier semiconductor companies in the world, we have exposure to the cutting edge technologies. And our in-house simulation team is equipped to handle this high-speed simulations, and we use state-of-the-art EDA tools with dedicated features to enable high-speed layout. And we also have a strong partnership with manufacturers around the world. We work with them closely well ahead, so that we use the right material and right stack up for the design. So the next topic is increased parallelism in ATE. Our customers are looking for opportunities to increase the site count in both in load boards and probe cards. Traditionally memory test boards used to have more sites, but we are starting to see ASIC test boards with site counts up to 32. Even ATE equipment vendors like Teradyne and Advantest, they're offering new platforms where the street area is more, so you can accommodate more that's right. What it happens to the PCB is that we have an extra large PCB, and there are challenges in designing it, and as well as for the manufacturer, they have to upgrade their system, the process equipments to manufacture the extra large PCBs. Tesol PCB team has over 2 decades of experience in designing ATE boards, and so we are well equipped to address these challenges. And we also offer feasibility studies to customers, especially in probe cards, where we have to we arrive at that pattern that is manufacturable and also has better touchdown efficiency. So we also work with manufacturers very closely, so we know which vendor can manufacture this large PCBs with a good yield and less cycle time. And also we have built in-house tools to validate site-to-site concurrency, which Yogan just talked about. And the last topic is AI and automation. We foresee that AI will have significant impact to the PCB design industry. The companies Cadence and Siemens are investing heavily, and their new versions are expected to have more AI features targeted to reduce cycle time and improve quality. Certain features like reusable blocks, auto interactive routing, we see that they have they can improve the cycle time. And outside the EDA space, there are startups as well. Uh, uh, they develop tools to reduce the design cycle time. A code-based schematic generation is one such example. At Tesol, I know we closely work with the EDA vendors, so we try to leverage the new features that they bring in, that's beneficial for our customers. And also we have partnership programs with universities to create customized tools. Right, so AT industry needs special automation utilities. So we know what the requirements are. So We have a dedicated in-house automation team as well. So we focus on creating such customized solutions in this ATE PCB space. So one such tool that we developed recently and we have successfully implemented is the auto tester channel assignment. So where we what used to be a manual process in assigning that pins to ATE tester pins, we have now automated and
Okay.
seen the cycle time improvement. That's all.
Thank you.
Thank you, everyone.
Thank you, Vijay. Next.